Hello friends, in this video we are going to see about inheritance in Java. So what is inheritance is when one class obtains the property of another class that we say as inheritance. So inheritance coming under an is-say relationship, and the main purpose of using inheritance is reusability. And in polymorphism, we will be using runtime polymorphism with the help of method overriding. If I want to make you to still more understand what does inheritance means, let me tell you an analogy. For example, if I have a father, so whatever my father have, I will inherit everything from my father. For example, if my father have a house and a car, it belongs to me as well, right? So I will say, if my father have a house and a car, I'll say I have a house and I have a car. So what happening here? I'm going to reuse it. I don't want to once again build a house, and I don't want to buy a car once again. I can just reuse it. So whatever my father have, it belongs to me. But what I have, it doesn't belong to my father. And this is what generally we can understand simply about inheritance. So in Java also, we can use it with classes and object. Let's see it with some examples. So for example, you consider there is a class. Okay, we already know what is class, what is an object generally in Java. So for example, if there is a class, and class contain two things, properties, that is data as well as functions. These two things present in a class. Let's say this class here have some properties like I and J. For simplicity, I'll say I and J. And it has some functions, let me say as display. So you consider this are the things belongs to class A. So the data is I and J and its function is display. So what I can do is I am going to have another class. I'm going to have another class called B, where I'm going to reuse the properties present in the class A. So if I want to reuse it, I want to use the concept of inheritance. For that, I have to use a keyword called extends. So extends and then A. Which one I want to inherit? That is the class A. So here I am going to extends class A. So then what happened is, here in class B, I am going to have some property called K. And here I can have another function called show, just for an example. Okay. So now class B, this class B inherit all the things from class A. So this is what inheritance. So if I say what are the properties or what are the data B class have, means I not only say K, I will say B class have data such as that, or the properties such as I, J, K. And what are the functions B class have? The B class have the function display as well as show. How does it have all these things? Because B class is inheriting everything from the parent class A. So that is what inheritance is. So this class A can be called with other names such as, this class A can also be called as parent class. Also, I can call it as super class. And also, I can call it as base class. So these are all the different name I can use for this class A. Okay, either parent class, super class, or base class. All are one. I can call it with different names. Similarly, class B is also called as child class. And it is also called as subclass. And it is also called as derived class. Okay, so this is a simple example where you can understand inheritances. Then let me have a function, another class called demo. Let us see, let us create an object and see how we can, how this inheritance is helpful for us. Okay, let me here, I'll have the entry point of Java, that is main function, public static void main. And this you all know, right? It has only one parameter, that is a string array. So now here I'm going to create an object for the child class. Who is the child class or the derived class? B class, right? So you know how to create an object. B, the object name I'm going to say is B1 equal to new B. Right? All the other properties of normal classes and object is there. In addition to that, we are going to bring in the inheritance. The main purpose is reusing one class. So now if I say B1 dot, using this object, now I can access all the properties of parent as well as the child. So I can say B1 dot display. That is also possible. That is, display function is present in the parent class. See, so display is present in the parent class. That is also accessible through the object of B. Similarly, I can also, using this object of child, I can also access the function present in the child. That is show. Right? So what is the main purpose? Consider B can use the property of class A, that is ij. In addition to that, it can use its own property K. Right? Say for example, let us take now another example. This parent class, let us say a student class. Okay, so what are the general properties of a student? Student have general properties like name, they have age, and then address, register number. So these are all general properties of all the students. So I can have all these things. Let the child class, let us consider as a college student. Okay, this child class be college students. So college student will also have name, age, address, and register number. In addition to that, let us consider they have one more property called placement. Okay, placement. And so now what happened? Now a college student have name, age, address, register number. In addition to that, placement is also there. So this is what reusability. In the college student class, I don't want to once again declare name, age, address, register number. Instead, I can only have what is unique to the college student. So that is placement. I don't want to rewrite it. So I can avoid redundancy in it. So we can also create another class. Let us create another class called school student. Okay, I'm going to have another class called school student, which is also going to use extends student class. So now school student will also have the property called name, age, address, and register number. So that we are getting from the parent class student. In addition to that, school student may have another properties like maybe just for an example, I'm saying they have a subject called physics. They have subject called social. Okay. So social science, maybe some other subjects. So school student also have name, age, address, register number. I'm not going to create those data here again. I'm not going to rewrite it. So I can avoid redundancy. Right? I am just reusing it from the parent class student. In addition to the name, age, address, and register number, the school student have this property for physics mark, social mark, and some more, whatever maybe you can add it. Similarly, here for the college student also have name, age, register number, address, and all. So in addition to the college student have a property called placement. So the common thing which can be used for more than one class can be kept as a parent class, and the specialized thing belong to that particular class alone can be defined in the child class or in the subclass or in the derived class. So now you can understand from this example, school student is also using the parent class student, and the college class is also using the parent class called students, and both of them are reusing the properties like name, age, address, and register number. In addition to that, the school student is having the physics, chemistry, social maybe marks, and in the college student, they have a special property called placement. So now you can understand the definition clearly. Inheritance is what? One class, maybe college student or school student, whatever may be, acquiring the properties and behavior of all of the other class. Here the other class is student class. So the one class get all the properties of the other class. Here in this case, student class. And also I said inheritance is a relationship, which means what? School student is also a student. That is a relationship. College student is a student. So that is what inheritance represents, is a relationship. School student is a student. College student is a student. So both of them are reusing the properties of the parent class. So this is what the general introduction. So the main advantage of using inheritance is reusability and also method overriding. So method overriding helps us to implement one of the or object-oriented concepts of Java, that is polymorphism, that we'll see with an example. So I hope you got some idea. Now let me also discuss the different types of inheritance. So types of inheritance. So there are generally 4 types of inheritance are there. The first one is simple inheritance. That is simple inheritance. What is simple inheritance? Let's say there is a class A. Okay, and there is also another class called B. So when class B use class A, this is called simple inheritance. So what I can say, when class B is going to reuse the properties present in the class A, this is called a simple inheritance. The second type of inheritance is multi-level inheritance. Multi-level inheritance. Okay, so what is multi-level inheritance means? Let's see an example for that. There is a class A, okay, and also there is a class B, and also there is a class C. So now, what is the meaning of multi-level inheritances? Class C is going to use the properties of class B, and class B is going to use the properties of class A. This is multi-level inheritance. So for example, the class C may be the son. Okay, son is going to inherit all the properties from the father, and the father is going to get all the properties from the grandfather. So, which means what? All the properties belonging to the father as well as the grandfather will belong to the son, right? Let's say, for example, class A. Let it be class A have the properties like I, J, okay? And let me say another class called B, which extends or which inherit class A. So, this class B have a properties like K, okay? Now, let me create another class C, which extends or which inherit class B. Okay, now this class C have the property called L, okay? L. Okay, so now if so now class C have, what are the properties belong to class C? Now class C have property called I, or the data you can have the properties like I, J, K and L. So now the C can use the properties of K, its parent. Also, since the parent is inheriting the properties from the grandparent, that will also belong to C. So C have all these things. That is what C. So what does B class contain? B class contain the properties such as I, J and K. What are the properties of A? A have only I and J. Okay. So B have this parents as well as its own. And C have its parents, and the parent's parent will also belong to this one. So this is what the next example. This is what the second type. Okay, let us see the third type of Java. Third type of inheritance, Third type of inheritance is hierarchical inheritance. Hierarchical inheritance. What is this hierarchical inheritance means? Let's say there is a class A. And here I have class B, and then class C, and also I have class D. Okay, so there are many class I can have like this. So this is hierarchical inheritance, which means what? Class B can make use of class A. Class A is also making use of the properties of class A. Class D is also making use of the properties of class A. So let me say, so I'll say if I want to code it, so class A is there. So it has the property of I and J. So, and similarly, I'm going to have another class B, which is going to extend the properties of its parent A. Okay. It can have the property like K. And also I have another class called C, which is going to get the properties from the class A. So it has some class called X, comma Y. And I can also have another class D, which is going to use some properties, use the properties from the parent class A. And it can have the properties like Z. So now if we discuss, so what are the properties of class A? It is I and J. Now what are the properties of B? I, J and K. What are the properties of C? Who is its parent? A. So it has the parent's property, that is I comma J, as well as its own property. So what are the properties of D? Are the data, okay? Data of D, it has, who is its parent? A. So parents' data are I and J. Property is the data, okay? Don't think something else. Property means data of the class. So I, J and its own data Z. So this is called as hierarchical inheritance. So the fourth type of inheritance is hybrid inheritance. Okay, hybrid inheritance. Okay, what is this hybrid? From the name itself, we can have the combination of one or two inheritance here. So let me have a diagram for you. So let us take like this. Here I have a class A, and here I have class B, and then I'm going to have like this. This is class C, and this is class D, and this is class E. So what is the meaning of it? I have a hybrid type of inheritance. So here I have single inheritance, right? This is single inheritance. And this is hierarchical inheritance. Inheritance. Okay, so when we are now we have hybrid inheritance. So single inheritance as well as the hybrid inheritance. So what is the meaning of this? B is inheriting A, C class is inheriting B class, and indirectly it is also getting the property of A. And here what is the meaning? D is inheriting the class properties of B, and B is inheriting the property of A. So indirectly D is getting the property of B as well as A. A's property is indirectly received by D. Here also E is inheriting B, and then it will also indirectly get the property of A. So directly it is connected to B, and since B is connected to A, so this classes will also get the property of A. So this is a hybrid inheritance. Since we have single inheritance as well as the hierarchical inheritance in place. So this is all about the different types of inheritance. Okay, so I hope you got some introduction. Now let us see an example, okay, so that you will be little more clear about how to practically use this inheritance. So let us see this problem. What is the problem given? Develop a Java application using inheritance as per following. Create a class shape. So let us create a class shape. Okay. So let me create a class shape. Okay. And then what else is said? Use this class to store two double data type value that will be used to compute the area of the figure. So it is said that we have to use two double type data value to calculate the area of a particular figure, whatever may be the shape. So let me take it generally like dimension 1, and also I'm going to have another double, no, the data type is double. So instead of integer, let me say as double. So here also I'm going to use another double variable. So this is the instance variable, right? It is not a local variable. The variable belongs to the class. So two data type is ready. What is then given in the question? Derive two specific classes called triangle and rectangle from the superclass shape. So we have to create two derived class. One is triangle, another one is rectangle. So let me create another class called rectangle, and which is going to inherit. So what is the keyword? Extends. I want to inherit the parent class shape. So this is one kind. Okay. And also it said create another class called triangle as well. Two specific classes. One is triangle. So let me create another class called triangle. Okay, so it is also going to use the parent class shape, right? Single parent, and now two classes is going to use this parent. So what type of inheritance is this? This is a hierarchical inheritance, right? So that is what we saw here. So this is the shape class, and here we have rectangle class as well as the triangle class. So in this question they are asking a type of hierarchical inheritance. Okay, then what is given in superclass? Add necessary getter and setter to initialize the data shape class data members and another members to find area and to compute and display the area of a figure. So the main objective is to calculate the area of the figure. So shape is general thing, right? So let me create void. And we have to calculate, there is a function find area. So let me say find area. It's a function we want to calculate the area of the shape. So here nothing is there to find because it is a general shape. So general shape doesn't have any area, right? So here let me say undefined shape. So for the parent, I'm not going to find any area. So for the child, let us create void find underscore area. Okay, so we can say for rectangle, let me find the area equal to, I can say dimension 1 into dimension 2. And then I'll say, okay, so this is double, right? Because dimension 1 and dimension 2 are double. And then we'll say system.out.println. We'll say the area is the area of rectangle is rectangle is, we'll say, plus area. Similarly, for the triangle also, we are going to do it. So here we are going to find it by, I guess, into divided by 2 maybe. Okay, I'm saying I'm just calculating somehow the area. And here I'm going to find it. So here I have taken to calculate rectangle, I just multiplied this. For triangle, I just multiplied and divided by 2, just for example. Okay, so I have did it. So I hope you got it. Override the display area from subclass. So this is what we did now. Overriding. What is overriding? See, there is a function called find area in the parent. with the return type as void and there is no parameter in it. Same function with same return type, same function name, same parameter. There is no parameter here. Here is also no parameter, which is defined in the child class rect. Okay, and similarly, same function, same return type, same signature. Right? Here there is no parameters. That is what called a signature. And but the content present in this is different. So this is called overriding. Overriding means what? Same function name, same signature, same return type present in the parent as well as the child class. So a function which is present in the child class will also be present in the parent class. So if you have the same function name, same, every signature same, but present in the concept of inheritance, then it is called as overriding. Overloading means what? Function name alone will be same, signature may be different, but present in the same class. That we'll say as function overloading. But overriding means everything is same. Return type, function name, parameter list, everything is same, but it's present in the different class in the concept of inheritance. That is what called as overriding. And along with that, if you want to have something like void, display here, you can have your own functions of that particular class. That is not, there is no restriction. You can have any number of other classes as well. You can say system.out.println. You can say I am in rectangle class. Similarly, I can say another function here in this triangle class, just I am showing, okay, we can have any number of specific function belonging to that particular class. I can say I have to have a function called show. Here I can say, which is present in the triangle class, I say system.out.println. I can say I am in show function of triangle class. So this is all about function overriding. So now let me show some more thing. So if you can have some more properties or data for this class, yeah, let's say for example, integer, let me say try equal to 100, just for your example. Okay, here I'm going to have a property or a data called integer rect equal to 200, just I'm showing. Okay, so what is the meaning? In addition to the dimension 1, dimension 2 of the parent, I can also have what? This rectangle class also have a property called rect, or the data called rect. Similarly, and you know the constructor, right? I can also have the constructor. So you know the constructor have same name as that of the class name. So here I'm just having a constructor. So which is going, let us receive the value of dimension 1 and dimension 2. So let me say double on D1. And for the second dimension, I'm going to get D2. So the purpose of the constructor is to initialize the data members of the class. So the data members here is dimension 1, that is initialized with D1. And the second data member is dimension 2, that I'm going to initialize with D2. So this is a constructor. Similarly, I can also have all the things. So here, you can also have a default constructor as well. Okay, so that is what it's saying. So in the default constructor, let us say dimension 1 equal to 0. And also for dimension 2 equal to 0. So it's all purely depending upon the application where you're working on. So now here, I can have my own constructor here for the rectangle. So how will you have a rectangle constructor? So here, let me have rectangle constructor with the same name of the class name rect. So this can be a default constructor. So this default constructor, this have 3 data, right? One is dimension 2, and the specific one of this is rect. So what can I do? I don't want to reinitialize this dimension 2 because dimension 1, dimension 2 is already present in the parent. So I can call the parent constructor using super. It's a keyword, okay? Super keyword help you to call the immediate parents properties also function. So this will call the parent constructor. If you don't use that also, it will automatically call it. If you don't use this line also, implicitly it will call it. Okay. And then what is the, let it be. And here we have only one property extra that I'm going to do here. Similarly, I can also have a parametric constructor. So rect. So here, this, sorry. So this parametric constructor. So what are the properties of rect? Rect have three things, dimension 2, as well as this rect. So it needs three things to do, right? So what are the things? One is double dimension 1 and also dimension double dimension 2, as well as this class have a property called rect. For that is an integer data type. For that I'm going to get R. So now what I'm going to do is to initialize this dimension and dimension 2, already it is there in the parent class. So what is the purpose of inheritance? Reusability. So I can reuse it. So what I'll do is I'll call the parents constructor with the help of the keyword what? Super, where I will pass this D1 and D2 there. So I can reuse it. I can reuse this constructor to initialize this dimension 1 and dimension 2. But this rect class has its own thing, right? That I can initialize it here. Rect is equal to R, which is I am receiving here as a parameter. Same thing you can do with this for the triangle also. Okay. So as of now, let us have only triangle default constructor. Right? If you put super or if you doesn't put super, this one, this line, implicitly it will be there. We will check that as well. So we will check all these things. Okay. So the parent have default, this is constructor overloading, which is present in the same class, right? Same function name, same constructor name, but different signature. Here there is no parameter, there is a parameter. This is called constructor overloading. And here also I have a constructor overloading for this rectangle class. Hope you got it. Okay. So now in the display function, I will also teach you another keyword. For example, if I want to call, so for this FindArea function, which is present in the parent, how can I call? I can call it by, I'll just use super keyword. I'll say super dot, see, I can see FindArea, see, FindArea function. So super keyword help you to call the parents function as well as the property. We will also do one thing. We will say system.out.println. We will call super dot dimension 1. So what is dimension 1? It is one of the property of the parent, right? Dimension 1. That I can call it here with the help of super. So that is the purpose of super. So what is the purpose of super? Super you can use like this, which will help you to call the parents constructor. So super will also help you to call the parents function. Super keyword will also help you to call the immediate parents properties or the data as well. Okay, so this is all about what? Function overriding. This is function overriding. And also I have taught you how to write a constructor here. Okay. So now let us come to the main function and let us use it. Okay, already I told you we have used a form of hierarchical inheritance. What is the meaning of it? Rectangle class can have all the properties of A, and also triangle class can use the properties of A. This model only we have created here. So first, let us create an object of who is the parent? We have a parent called shape. So let us create an object for shape. Shape is equal to new shape of. So now let me say yes dot, there is a function called FindArea, right? So FindArea I'm going to call, I'm just using only parent class, okay? This is my parent class. There is a function called FindArea. I just calling it, and let me run it. So FindArea is also present in the two childs as well, but I'm using the parent object. Using the parent object, I'm calling FindArea. So which one will be called? This will be calling the parents FindArea. So let us run and check it. So now you can there is an error. Let's say what it is. Exception in the thread name. No such method. Shape.FindArea. 1 minute. Okay. Okay. In my already I have a class called shape already in my list. So what I will do is I will rename shape as shape1. Okay. I think then the problem will be solved. So let me make it as shape1, because say shape1 is already there in my, already I have created it. Okay. So here also I have to put shape1. Similarly, for this class also I have to put shape1, and here also I'm going to use shape1. If the same class already available, then it will get confused, right? Now let us run this program. So now we got the answer, undefined shape. So right, undefined shape. So when I call FindArea, this is calling the parents FindArea. In the parents FindArea, what is there? Undefined shape is there, right? Now let us create an object for the child classes. And okay, one more thing I said, child can access everything from the parent, but the parent cannot access everything from the child. I told you, right? So let us check that. Now using this parent object, let me call a function which is present only in the child is child rectangle. Rectangle class is a child of shape1, right? In that they have a class called function display. Let me try to call it. See, dot display. Even display is not displayed here as well, but still let us try it. What does it show? You can see there is an error. What does it say? The method displays undefined for the type shape1. So from that, you can understand the parent cannot access anything from the child. Even I can try to get a function show, which is present inside the triangle class. If you see, for that also it is showing the same error. See, show is present in the child class. So that I cannot access it. So parent cannot access anything from the child. So now let us create a object for Rect. Okay, Rect class. Here is a class called Rect, R-E-C-T. And let us try to access the different thing. Rect, let us say R1 equal to new Rect of. Okay, so now let us see. Let me write one thing here. Okay, in the Rect class, let us say system.out.println. I am in Rect class. Okay, just for your understanding, to make you to understand how the this is called. So here, let us say system.out.println. I am the parent. So now what happened? I'm creating an object for this child class, right? So when I run it, so let us just to make you clarify, I comment this 2 line. So we have created an object for the child class. So what will be the output? You can guess what will be the output. So whenever you create an object, automatically the constructor of this particular class will be called. So it will come to the constructor, default constructor. That is what we are calling here, right? So we are calling a constructor without a parameter. So directly it will come to this place. And here we are calling super. So which will go to the parents constructor. In the parent, it shows I am parent and it is initializing. And then it will come back to this place, and here it's display I am in rectangle class and initializes data member. Let us run this and see. So you can, first it is going to the parent and then it is displaying it because of the super keyword. Let us do one thing. Let us command this super, and now let us try what happened. So I said super will be called if you put, or if you don't put, it will be implicitly called, right? That let us check it. See, even though I command the super, it is calling first the parents constructor. It shows I am parent. Then only it will coming back and it is printing I am in rectangle class and it initialize it. So what does it shows? When you have inheritance classes, first it will by default, the default constructor will call the parents default constructor. Then only it will come back to call its own constructor. And same thing, now you got it, right? The super implicit and implicit caller super keyword if you put, or if it doesn't put also, it will call its parents default constructor. Okay, now using this R1 object, let us call the FindArea. So if I call FindArea, what does it do? Okay. So FindArea, in the rectangle class, we have FindArea. So it will come and call this. What is the value of dimension 1 and dimension 2? By default, it is 0, 0. That is what we have initialized. If you want some value, we can pass it here. And let us say dimension 1 is 1, 2. So what does it do? Let us say as 1.0, because it is accepting the double type, right? Point. And it also need one more parameter. See here, it needs 3 parameters. And the last one is rect. For that, let us pass some 4. So now all the error gone. So what happened? 3 values we are passing. So because in this constructor, we want 2 double values and 1 integer value. And this 2 double value will be passed to its parent. So the dimension 1, dimension 2 will be initialized. And it will come back here. And this third integer value will be initialized or assigned to this rect. So now with this initialization, if we call FindArea, so it should multiply 1 into 2, right? So that is what present in the FindArea of rect. So it does multiply dimension 1 and dimension 2, which is initialized in the parents constructor. And then it says the area of the rectangle is, and we are displaying this area. So now let us run this and let us see what is the answer we are getting. So now you can see the area of the rectangle is 1 into 2 is 2. So we got it. Now let us try. So I said this can, child can access everything from the parent. Now let us do one thing. We can try to access some function. Let us have it in parent, okay, check. Let us say system.out.println. You can say I am parent check. So now if I call the parents check, already we saw it, but still we do, right? R1 dot check. So R1 is what? Child's object. Using child's object, I can even access everything from the parent. Until otherwise, the parent keep it as private. Okay, so we understood it. Same thing you can do with the rectangle also. For the rectangle, you can create an object and you can also call these functions. Okay, I hope you have got all these things. So parent doesn't access child. properties or a function, but child can access all the things from the parent. For example, let us do one thing. Let the parent make it as private. Okay, I'm going to make it as private. Okay, I made it as private. Now you come and see here, you'll get an error. See, now you cannot access it. So if the parent make it as private, then the child cannot access. Okay, if my father say, I will not give you my property, then I can't. But generally, I can acquire everything from my parent. But if it is private, if some restriction is there, we cannot. So if the parent make it as private, then you can't access. See, child object. What is child object? R1. R1 cannot access the private member. But if I take the private away, then I can able to access it. So now you can see there is no error. So you got it. Now the last thing we can see here is another concept called dynamic method dispatch. Okay. Dynamic method dispatch. So this is an important concept of inheritance where you can learn dynamic method dispatch is also called as runtime polymorphism. We can also call it as runtime polymorphism. Okay, what is this? Runtime polymorphism means? Okay, what is it? What does it mention is? It's a mechanism by which you can able to call the parents or reference variable can call the child's overridden function. Okay, so it's a mechanism by which a call to overridden method is resolved at runtime rather than the compile time. So, for example, let us learn it with an example so that you'll understand. We can already I told parent cannot access anything from the child, right? But the parent reference can access the overridden function of the child, only the overridden function of the child. That is overriding and is an example of polymorphism. So which function to be called is resolved only during the runtime, not during the compile time. Overloading is also a kind of polymorphism, that is static polymorphism. But this is function overriding is an example for dynamic polymorphism, or you can call as runtime polymorphism. So which function to be called is decided only during the runtime. But function overriding is static polymorphism, which means which function to call is decided during the compile time itself. Okay, so let us see example for that so that you will understand it clearly. Okay, first let me call an object of the parent. Shape S1 equal to new shape 1. Okay, so this is an object for the parent. Let me create an object for the child. Child rect equal to new rect of. So this is an object for the first child. Okay, we'll also create an object for this class as well. This is also another child of shape. Let me create it. T1 equal to new rectangle. Okay. Now we'll do one thing. Let me say shape. You can say S1 also. Let me create shape S2 also. Okay, I'll show different things. Now I'll say shape 1. Okay, that is the class name. So now I'll say S2 equal to S1. Okay, and then I'll say S2 dot FindArea. Okay, so I have created a reference for the parent. Using this reference, first I have assigned to this reference, I have assigned the object of the parent class itself. Then, so now, okay, now let us run it and let's see. What is in the FindArea of the parent? It says undefined shape. So when I run it, it's expected that we'll get an output of undefined shape. So, okay. So it is calling, you can see undefined shape. Why I'm getting all this thing? Because, you know, the default constructors are called, right? So for this, the constructor is called, it says I am parent. when this object is called, that time also it shows. Let us, as of now, let us disable all these things. Okay, so that you will get only the required output. So now if I run it, you will get only undefined shape. Okay, so if you say find area in the parents, find area, what is there? Undefined shape, that you got it. Now let us do the next thing. So to the reference of the parent, that is S2, I am going to assign the object of the child R1. What is R1? R1 is the object of the child class Rect. Now we say S2 dot find area. Okay, so now this will show the parents find area. There we have undefined shape. What does this show? Because to this reference, I have assigned the object of the child. So now it should call, using the parent's reference, I'm going to try to call the child's overridden function find area. What is in find area? The area of the rectangle is area. So as of now, dimension will be having default value as 0, 0. So we'll get the answer also 0. So now if I run it, you will get first line says undefined shape. Next line says the area of the rectangle is 0, 0. Okay. Now, hope you got it. Now let us go and do one more thing. In the same parent's reference, I'm going to assign this child's T1. That is the object of the another child. Now I'm going to say S2 dot find area. So now what will I get? I will get the find area which is present inside this triangle class. Triangle class. We'll say the area of triangle. So triangle class is also inheriting the shape. So in the shape already we saw dimension won't have 0, 0 value. So here again in the triangle, when you do the calculation, you will get the answer as 0 only. So now let us run it and see. Now we got the area of the rectangle is again we got a 0, 0. So first, so here you can see when to the parent's reference, when I assign the parent's object, it is calling the parent's find area. To the parent's reference, when I assign child's object, it's called child's find area. To the parent's reference, when I assign the rectangle class object, which is a child, it's called rectangle class find area, right? Now what we did is, using parent's object, we are trying to call the child's overridden function. But what I said, parent cannot access anything from the child, right? But only with the help of dynamic method dispatch, we can able to call the child's overridden function alone. Another functions cannot be accessed. And which function to call? Is it the child's find area or parent's find area? Whose find area is to be called is also decided only during the runtime. So that is why we call it as runtime polymorphism. Okay, so the decision to call which find area is taken only during the runtime. So that is why we say it is dynamic method dispatch. Dynamically, the method call is done during the runtime, also called as runtime polymorphism. Okay, let us do one thing. Now, using this S2, let me try to call another unique function present in the rectangle function, rectangle class. So what is the display? Let us try to call it and you will get error, okay? So let me call S2 dot, see display is even not coming also. So it will show you error. See, immediately I'm getting error. What is the reason? Display, if display is an overridden function, then it is possible. I can call the display with the help of parent's reference. But since display is not an overridden function, see, display is present only in the child. It is not present in the parent. See, in the parent class, we don't have a function called display. So using parent's reference, you can call only the overridden function. Other property or other function, we cannot call it. So you have to understand parent cannot access anything from the child. So only thing is using runtime polymorphism, parent's reference can access our parent's object also. Even if you put here S1 also, it is possible. So if I say S1 is equal to R1 and S1. So using parents object, also you can able to access the overridden function, but you cannot access anything else. So this is called as runtime polymorphism. Now, if you see the question, it is also asked, override the display area that we did it, right? Find area function. We instead of we overrided find area itself, so no problem. And you can do it in any way. Then complete above scenario using inheritance, and it's also as runtime polymorphism. So we did that as well. So this is called runtime polymorphism. So using the parents object or the parents reference, we can able to call the overridden function, and it is resolved only during the runtime. Okay. So hope you got it. Thank you. God bless you.